Hello. Today I'd like to talk about the classification of matter, the way that we as chemists differentiate between elements, compounds, and mixtures. We're going to be able to describe these three different things, as well as look at models of elements, compounds, and mixtures. But first, let's tackle the question of why we classify different substances. What does this matter? What's the big picture here? Well, if you've ever seen one of my favorite demos, you'll start to understand a bit about why chemists are interested in this. One of my favorite demonstrations involves taking sugar and mixing it with one of the strongest acids we know of, sulfuric acid, H2SO4. If you do this, you're going to get a wonderful chemical reaction that produces this big black billowing snake out of your glassware, lots of steam, lots of heat, very toxic actually. You should do this in a fume hood, or at least a place that's well ventilated. Really, really neat chemical demonstration. And what it shows us is something that's early scientists and early chemists were really, really interested in. If you take sugar and sulfuric acid, you get a new substance when you mix them together. What this starts implying is that this substance has a different composition than that one. It's made of different things. And you can do further tests to show that the sugar, one of the things that makes up sugar, is this. So sugar is made up of multiple things. And we started figuring out that those things, we called them elements. They were the things that make up other things. And then we called those compounds. You'll start to notice it's a way that we can start making sense of our world. We start noticing that there are parts to our wholes, that mixtures contain different things. And so that's why chemists are interested in this, because it allows us to start making sense of the chemical reactions that we see going on. Now, I want to show you one big chart here to start off with. This is a chart of the one way that chemists might organize our classifications. There's lots of different words here, but we're going to start right here with, if you take matter, what is the most basic thing that you can ask about matter? Well, the most basic one involves whether something is a substance or is it a mixture. A pure substance is something that we're going to say has a definite fixed composition. Take that sugar that we were talking about before. Sugar is sugar. If I buy sugar at Tops or at Wegmans or at any store, sugar is sugar. At least table sugar is table sugar. That fixed composition doesn't change between different samples. So pure substances are something that are always there, whereas a mixture is going to be some combination of two or more substances. And that combination can vary. In fact, back in our demonstration, this sulfuric acid is actually an example of a mixture. It's going to be a mixture of sulfuric acid, H2SO4, and water. And that composition can vary. You can have really strong sulfuric acid, highly concentrated. You can have really weak sulfuric acid, low concentration. So you have to ask, well, how strong is this mixture? Whereas for sugar, you don't have to ask how strong the sugar is. You don't have to ask how much sugar is in your sugar. Sugar is sugar. It's a pure substance. Sulfuric acid is a mixture of two different things. So it has a varying proportion there. Now, within the pure substance realm, you can have two other different things. You either have elements or you have compounds. An element is a substance that can't be decomposed into simpler substances. These are the things that are on the periodic table. You think of hydrogen, oxygen, nitrogen, carbon, all of those different pieces that make up other substances. Those are our elements, and those get combined then to make compounds, such as water, carbon dioxide, sulfuric acid. Those are substances composed of two or more elements. Now finally, you can have lots of different types of these, but let's get into our different types of mixtures here, because those are important for us. There are two different main types of mixtures. We've already said that a mixture can have a varying composition, but it can also vary in terms of how that mixture is put together. A mixture is homogeneous if it has the same composition throughout. We call that a solution. So that's sulfuric acid. It doesn't matter what part of the sulfuric acid I use. That sulfuric acid was the same throughout. The air in this room is another good example of a homogeneous mixture. It doesn't matter where I am in the room. The air that I'm breathing all has the same combination of elements and compounds in it. Whereas you can also have heterogeneous mixtures, which vary in their composition, or another better word for it might be their texture or their appearance. If you think of something like a soup, I like to think about soup as a mixture, right? You have vegetables, you might have meat in there, you might have different liquids, all in your soup. But each bite of soup might have a different proportion of those different things. They might be different in terms of their composition. And so heterogeneous mixtures, they do change. Now, you might have seen different models of elements, compounds, and mixtures before. They look like this in terms of particle diagrams. And so one skill you want to have is being able to identify and describe different models of elements, compounds, and mixtures. So let's take a look at A, for example. In A, it looks like we have this blue substance, or these blue atoms, connected to 3 white atoms. And that doesn't change. It's the exact same thing in every one of those pictures here. So that leads me to indicate that this is a substance. In fact, it is a pure substance because it has the exact same composition everywhere. It is always this. And in fact, we would say that this is a compound because it's composed of 2 different elements. Contrast that with B. B looks to have different substances inside of it, and they're not all mixed together. They look like this. This could vary in composition. I could have more of these 2 blue atoms together, or I could have more of these 2 white atoms together. So we would call this a mixture. It's tough to tell if you could call this homogeneous or heterogeneous. You'd have to see maybe a bigger sample, but you could make a claim, I think, that it was either heterogeneous or homogeneous, depending on what you wanted to claim here. And then we could actually say even something further. Is this a mixture of compounds, or is it a mixture of elements? Well, it looks to me like we have 2 white atoms here and 2 blue atoms there. They're not combined together to make 2, so this is actually a mixture of elements. Diatomic elements, to be more specific. Finally, C. You might have already looked ahead and taken a look. C is pretty simple. It's just got purple atoms, and that's it. So this is a pure substance, and it is an element. And then finally, D, again, looks to be just one thing, a pure substance. And once again, this is an element. It can be sometimes confusing to see how this is an element and this is a compound, but it's because this only has one type of atom in it. That type of atom, that element, is red, and we have combinations of those red elements, but there's no other element in there. That's what makes it just an element and not a compound. So I hope now you can describe the differences between elements, compounds, and mixtures, as well as pure substances versus mixtures, and taking a look at homogeneous and heterogeneous mixtures. Thank you all. Have a fantastic day.